In this video, we're looking at isosceles and equilateral triangles. So define an isosceles triangle and label all parts. So an isosceles triangle is a triangle that has two congruent sides. It has one vertex, two legs, two base angles, and a base. Define an equilateral triangle. Well, an equilateral triangle is a triangle that has all three sides congruent and all three angles are also congruent, which will be exactly 60 degrees for each angle. Base angle theorem. The base angles of an isosceles triangle are congruent. So these are the angles that are opposite the legs. So let's take a look at this proof. Given an isosceles triangle, DEF, with segment DE congruent to EF. So the first statement is given. And then the second statement, construct an angle bisector. So for every angle, there is one angle bisector. So what does that do? It makes angle DEG congruent to angle FEG, because that's the definition of an angle bisector. And then we can say that segment EG is congruent to segment EG because of the reflexive property. And then we can prove that triangle DEG is congruent to triangle FEG because of the side angle side postulate. And then I can say that angle D is congruent to angle F because CPCTC, congruent parts of congruent triangles, are congruent. And those are my base angles. Isosceles triangle theorem. The angle bisector of the vertex angle in an isosceles triangle is also the perpendicular bisector to the base. Okay, so let's jump back up to the last proof here and have a look at this. So we already know that these two triangles are congruent. So angle EGD is congruent to angle EGF, and they're a linear pair. So therefore, these two angles are 90 degrees. And we know that segment DG and segment FG are congruent because of CPCTC. Therefore, segment EG is a perpendicular bisector to segment DF. Okay, example 1, which two angles are congruent? Well, the base angles are opposite the legs, so that would mean that angle S is congruent to angle U. Example 2, an isosceles triangle has base angles with measures of 47 degrees. What is the measure of the vertex angle? So I can set it up as the vertex angle plus 47 equals 180. Solve for V, and I get 86 degrees. Example 3, if an isosceles triangle has a vertex angle with a measure of 116 degrees, what is the measure of each base angle? So I've got two base angles plus the 116 degrees equals 180, and I can solve for the base angle and I get 32 degrees. Example 4, find the value of x and the measure of each angle. So the base angles are congruent. So therefore, we can set up 4x plus 12 equals 5x minus 3 and solve for x, and we get 15. Now we can find the measure of each angle by substituting 15 in for x. And so I get 72 degrees for the 4x plus 12, and then also 72 for the 5x minus 3. Base angles theorem converse. So if two angles in a triangle are congruent, then the opposite sides are also congruent. So if I know the base angles are congruent, then these opposite sides, which are the legs, are also congruent. The isosceles triangle theorem converse. The perpendicular bisector of the base of an isosceles triangle is also the angle bisector of the vertex angle. So we're just stating the converse of the previous theorem. Example 6, find the values of x and y. First equation will deal with the legs that are congruent. So we can say that 5y minus 1 equals 2y plus 11. And then we can solve for y. And we get y equals 4. The solving for y, we deal with angles. So we know we have two base angles and one vertex angle. So if we add all three of these together and set it equal to 180, we can solve for x. So I have two base angles and one vertex angle. And when I add these together, I get 7x plus 5 equals 180, and solve for x. And I get x equals 25. And that's it. So I hope this makes sense. Try the practice set